We trust AI with so much these days. Driving our cars, helping doctors diagnose diseases, even securing our data. But what if these incredibly smart systems have a hidden and, honestly, a shockingly simple blind spot? Well, that's what we're digging into today, looking at some critical research that exposes just how fragile our smartest machines can be.
I mean, get this. It sounds like something out of a movie, but it is 100% real. This quote right here points to a pretty terrifying vulnerability. A few little pieces of tape, something you or I might not even notice, could trick a self-driving car into making a catastrophic mistake. And here's the kicker. This isn't a bug. It's a fundamental aspect of how these systems can be manipulated.
And that really is the million-dollar question, isn't it? If AI is so powerful, so advanced, how on earth can it be fooled by such simple, almost silly tricks? The answer, it turns out, reveals a fundamental weakness that we're really only just beginning to wrap our heads around.
So this fragility, it has a name: adversarial attacks. This is the hidden blind spot we're exploring. And just to be clear, we're not talking about random glitches or system errors. No, these are deliberate, carefully engineered deceptions that are aimed right at the heart of an AI's logic.
Okay, so to really get this, we need to talk about what an adversarial example even is. Imagine, you have a picture of a cat. An attacker adds a layer of what's basically digital static. It's so tiny, so subtle that you can't see a difference. To you, it's still a cat. But to the AI, it now says with total confidence, that's a toaster. That's an adversarial example. And believe me, this isn't just some weird academic thought experiment. These kinds of attacks have serious life-or-death consequences. We're talking about everything from self-driving cars on the highway, to the medical scans a doctor uses to find a tumor, to the Face ID on your phone, and even massive national security platforms. The stakes really couldn't be any higher.
But here's where it gets even more complicated. The problem is getting deeper, because AI itself is changing. The threat is evolving right alongside it. We're moving way beyond simple AIs that just classify things. We're now dealing with systems that can think, plan, and actually act on their own in the real world.
So what's the difference? Well, think about it like this. A spell checker is a pretty static AI, right? It sees a misspelled word, it suggests a fix, end of story. But a self-driving car, that's what we call an agentic AI. It's constantly perceiving the world, thinking about what to do next, and then acting, over and over again. And that distinction, as you'll see, changes absolutely everything when it comes to security.
This really breaks it down nicely. Your static AI, like an image classifier, does a one-and-done task. It looks at a photo and gives you an answer. But an agentic AI, like an autonomous drone, is caught in a continuous loop. It's always sensing, updating its internal map of the world, and then acting on that information. And that persistent, ongoing loop creates a whole new and much, much bigger attack surface.
So when we talk about agentic AI, this is what we mean. The keywords to focus on here are autonomy, self-governance, and persistent entities. We're not just trying to trick a single decision anymore. We're potentially talking about hijacking an entire continuous process of decision-making.
Okay, so how do we even begin to secure something like that? Well, the researchers in this paper propose a new framework for thinking about it. Instead of just one point of failure, we need to start thinking in layers. This is really the core of their contribution.
And it's brilliant, really. They break the threat down into 3 super intuitive stages: seeing, thinking, and acting. An attacker could mess with what the AI sees. That's our stop sign example. Or they could attack how it thinks, corrupting its internal map of the world. Or, and this is the most dangerous, they could find a way to directly hijack what it does.
And this is where it gets truly scary. You can get this cascade effect, a tiny, almost insignificant error in perception, like seeing that stop sign as a yield sign, can then propagate through the whole system. It causes the AI to think the road is clear, which finally leads it to act by accelerating right through an intersection.
So this whole multi-layered threat model, it opens up a brand new frontier for research. But here's the unsettling part. According to the paper's own analysis, it's a frontier we've barely even started to explore.
The researchers did what's called a bibliometric analysis. Basically, they counted up all the published studies on traditional adversarial attacks, the ones that trick static, one-shot AIs. And they found 973 of them. That's a solid, mature field of research.
But then, they look for studies on these new agentic threats, the ones that target the AI's ability to think and act over time. How many did they find? Only 101.
That huge gap between those two numbers, that's the blind spot. It tells us that even as our AI systems are getting more powerful, more autonomous, our understanding of how to secure them is lagging way, way behind. It's like we're busy building self-driving cars, but we're still mostly studying how to secure spell checkers.
And look, the tools for these attacks are already incredibly sophisticated. We don't need to get lost in the alphabet soup here, but just look at that last one, the CNW attack. It has a nearly 100% success rate, and its stealth score is incredibly low, which means the changes it makes are almost impossible for a person to see. These powerful tools are already out there for static AI. Just imagine what they could do when they're adapted for these new agentic systems.
So what do? It's a pretty daunting problem. But the paper doesn't just sound the alarm, it actually charts a path forward. The key is that we need a fundamental shift in how we even approach AI security. Ultimately, it all comes down to this massive shift in thinking. It's no longer good enough to just secure a single input, like one photo. Now, we have to find a way to guarantee the good behavior of an AI agent over its entire life, securing its whole decision-making process from beginning to end.
And that means we need a whole new game plan, a new research agenda. We need brand new tests that don't just measure an AI's accuracy, but its autonomy and its memory. We need defenses that protect seeing, thinking, and acting. This is basically a call to action to build an entirely new scientific field, one dedicated to securing these thinking machines.
This quote from the paper just nails it. It perfectly sums up the new way of thinking. Robustness, or security, isn't just a feature you can program into an AI anymore. It's something that has to emerge from the way the agent interacts with and learns from the real world, day after day.
Which leaves us with a final and pretty crucial question. We've gotten really good at debugging code, but as we start to hand over more and more control to autonomous AI, the real challenge is going to be securing its judgment. And based on this research, that's a challenge we're only just beginning to truly understand.